All right, so now time to go ahead and build a little function for this bad hash algorithm, then play around with it a little bit. So hopefully on my screen, you can see my initial string that I'm wanting to hash. So this hello world, which I've labeled as string to hash. Just a couple early printout things just to make sure that we're all in agreement with what's going on here. So the first thing I'm going to do is clean all that up so I don't have all of that junk all around. So I'm going to print out just that initial string, which is going to kick out hello world. I'm going to print it out as a list. So it's going to have each of these individual characters. Then I'm going to compute the ASCII equivalents of each of those characters. So in Python, that's going to be with this ORD command. So cycling through each of the values in my string, computing its ASCII value or its Unicode value in general is going to kick out that 72, 101, 108, 108, 111, and so on. I'm printing that out here. And then I could also do the binary version of this thing. So if I do basically the same thing that I did for this process of converting it into the ASCII, I'm going to take those values and then now compute them into binary. So this nice little bin function. Officially, that's going to print out with the 0b. So if you don't want the 0b in it, you can start at the second index and then print out from there. And let's get that going again. And I should hit go beforehand. Let's give this thing a reload and then we'll make sure that it's all up and running. Get out there, new hidden. All right, print it out there. All right, so now we don't have the little the 0b there as well. If you wanted the hex version of it to make it look extra cybery, you could change the word binary into hex, change the bin into a hex as well, and then change this to hex on the back end here. All right, so if I run that, you can see the hex values for it as well. So the hex one would have started with the 0x as well. So if you want to chop that part off, you can give it the 2:. Neat. All right, so our goal is then going to be to define this bad hash algorithm. So what I needed to do here is I'm going to XOR all of these things in pairs. So I need to XOR the 72 and the 101, which I can simply do by printing out 72 XORed with the 101, and that's going to print out my next value, which would have been the number 45. So 45, if I wanted to view that in binary, I can convert that as well. So I print that and go from there. You can see that that should hopefully be my first output. So is that I would have had my 1001 triple zeros. That one XORed with the 11000101 is then going to collapse down into 101101. So basically that's the process we're going to do over and over and over and over again. So I'm going to initialize this thing to be a D, which is going to be a 0. So that's going to be my final digest. So then what I'm going to see is I'm going to say for X in my Unicode list. What I'm going to do is I'm going to say D is then going to be D, the current D, XORed with the next value. And then at the end of the day, I'm going to print out what that D happens to be. We can technically do this in one swoop as well. So we can do D reassignment here with the XORed against it. So either of those two objects work. Sweet. So that's going to print out the D as a decimal. If I would like to, I can convert that thing back into binary. And then at the end of the day, I can also print that out as, let's say, a hex. So if I hit go on this, I should hopefully see the number 32 emerge, which is what we saw. At least that's what I claimed earlier on the notes. So let's give that thing a run. So we do in fact see that hello world is going to hash, quote unquote, bad hash into a 32, which is then going to be 1 followed by 5 zeros or 20 in the hex land. So I actually got a full printed out version of this thing on D2L. So I'm going to give this thing a run just to have a few extra examples running. So here I've created the function called bad hash, which is going to do exactly what we just saw. It's going to generate the Unicode list, and then it's going to have this little loop, and then it's going to return the D. And then down below that, you're going to start to see, maybe once I give it a reload here, you'll start to see a few different examples where I'm running that same game over and over and over. So we have the hello world, which is going to have a hash value of 32. We see that password 1 bang is going to have a hash value of 47. Password like hello world's got a double S in it. So I could change the double S to the extra cool double $, which is then going to result in a hash value of the same of a 47. Also, 47 is going to be connected to the /. So actually, I could just feed a / and it would see a 47 exist as well. I think if I wanted to, so if you wanted to think about what came from 32, so if I want to do what is the character of 32, I could see another example. Oh, the character of 32 is just a space. I probably should have known that, but alas, we maybe forgot. So example 1a. So here my string is just going to be a space. So if my string is a space, you'll see another example of something that's going to kick out 32 as well. So clearly my bad hash has got collisions galore. So then our question begins to think about, okay, how many things do I need in a list to maybe guarantee there to be some type of collision? So that's going to be our next point of discussion, chatting a little bit about the quote unquote birthday paradox. We'll come back and revisit the bad hash example just to play this game of collision to see how often the collisions are going to occur. And then we'll start upping the ante and begin looking at some slightly more sophisticated hashing algorithms beyond just our quote unquote bad hash. But the bad hash becomes a really nice example of seeing the pieces, seeing what not to do, as well as kind of initializing all of the tools that we're going to need a little bit later.